Welcome to this explainer. Today, we're diving straight into the Linux command line, and we're going to treat it like an explorer's journey through a vast, highly structured landscape. Look, if you've ever felt overwhelmed, or maybe just a little lost staring at that blinking cursor, today is the day we build your compass, because once you actually understand the physical layout of the file system, you unlock the true power of the machine. We're bypassing those clunky graphical interfaces and directly commanding the system. So grab your gear, and let's start charting the unknown.
Here is our quick agenda for today. We've got a clear syllabus of 5 foundational skills: mapping the file system tree, navigating paths, inspecting our surroundings, safely manipulating files, and finally, creating system links.
Section 1. The Linux file system tree, orientation in the command line. Let's establish exactly how our environment is organized.
Now, this perfectly illustrates a major difference you'll encounter if you're coming over from Windows. In Windows, you're probably used to completely separate drive letters, right? Like your C drive, your D drive. But in Linux, there are no isolated islands of data. Actually, scratch that, it's more like one giant interconnected web. Everything, every drive, every single folder, every file is unified into one single hierarchical file system tree. So there's absolutely no more hunting between drives for a lost document. It's all connected.
The absolutely crucial point here is that it all starts at the root directory. We represent this with a single /. It's the ultimate starting point for our map. Just a quick heads up, make sure it's a /. The Windows / is a super common stumbling block for beginners, so keep an eye on that. But yeah, think of this / as the literal trunk of the tree. If you start at that root, you can trace a continuous, unbroken path to literally any piece of data on your entire computer.
Section 2. Navigation and path awareness. How do I travel safely? Now that we have a map, we actually have to move. When you drop into the shell, you are always somewhere. You're never just floating in a void. Which brings up the most important question any explorer can ask. Where are you right now? In a normal graphical interface, you've got a helpful little window telling you your location. But in the shell, it's just you and that blinking cursor waiting for your next move.
We call this exact location your current working directory. And maintaining awareness of this spot is absolutely essential so you don't get lost. Every single command you run happens relative to this precise location. Now, your command prompt might give you a tiny hint, like showing the name of the folder right next to the cursor, but you need to know how to verify your absolute exact position in the wider terrain.
And to do that, you use the pwd command. This is your ultimate diagnostic compass. It literally stands for Print Working Directory. Whenever you feel even slightly disoriented, typing pwd just asks the system to hand you your exact coordinates. Seriously, even veteran system administrators will type pwd a dozen times a day just out of pure muscle memory. It's a totally harmless command, and it acts as your safety check before you make any big moves.
Okay, once you know your coordinates, the cd command, or change directory, is how you actually walk. And the flexibility you have here is awesome. You can use absolute paths, which means you type the full address starting from the root /. Or you can use relative paths, which is basically just stepping next door from where you currently stand. Plus, there are these amazing shortcuts. A single dot just means right here. Double dots smoothly bump you up one level to the parent directory, and my personal favorite, the tilde, acts as a teleport pad to zip you straight back to the safety of your home folder.
Section 3. Inspecting files and directories. What is around me? We've mastered walking. Now let's look around the room.
You can inspect exactly what's inside a directory using the ls command. The base command just spits out names, but adding options really illuminates the room. Pop on a -L for a long format that shows you file sizes and dates. Add an A to reveal hidden files. Combining them into ls-al is a massive game changer. It essentially acts as an X-ray, revealing absolutely everything in that folder. And just a fun fact, in Linux, making a file hidden is as simple as putting a dot at the very beginning of its name. Now, what if you spot a plain text file, like a system configuration, and you want to read it? Just use the cat command. You don't need to boot up some heavy text editor. Cat instantly dumps the file's contents right onto your screen so you can read it and keep moving. One quick warning though, be careful not to cat a massive gigabyte-sized log file or you'll literally be watching text scroll by like the Matrix for the next 10 minutes. Section 4. Safe file manipulation, interaction, and responsibility. We're moving from passive observation to active manipulation here. But before we build or destroy anything, we need a safe practice workspace. We'll use mkdir to make directories and touch to create empty files. Now, please remember this. Linux is strictly case-sensitive. File with a capital F and file with a lowercase f are two entirely different things. And regarding spaces and file names, just don't do it. It is a beginner's nightmare. If you use spaces, you have to use quotation marks or clunky escape characters every single time you reference that file later. Do your future self a huge favor. Just use dashes instead of spaces and keep it tidy.
This chart lays out our primary manipulation tools. CP handles copying, RM is for removal, and MV takes care of moving and renaming. Yep, in Linux, moving a file and renaming a file are actually the exact same operation. Also, pay close attention to those options on the right. The I stands for interactive. Think of it as a mandatory "Are you sure?" pause, which is great for beginners. And V is for verbose. It just tells the system to talk back to you and confirm exactly what it just successfully did.
Let's put this all together into a safe file removal procedure. Please pay attention here, because in the Linux command line, there is absolutely no recycle bin. When a file is gone, it is gone. Because commands like rm-rf can destroy a system in seconds, you should always follow these 3 steps. First, anchor yourself with pwd. Second, preview your target with ls. And third, always add -i to your rm command so you get one final chance to back out before you make permanent changes.
Section 5. Creating system links. Connecting the map. Let's see how we can build shortcuts across our tree.
By using the ln-s command, we can create a symbolic link, or a symlink. This is incredibly handy for referencing a file without actually copying it. Think of it exactly like a desktop shortcut. If there's a massive file buried 10 folders deep, just drop a symlink in your home folder. Instead of duplicating a huge file and eating up all your storage, the symlink just directs traffic back to the original. And when you run that ls-l command we talked about, you'll actually see a cool little arrow pointing directly from your shortcut to the real file.
So, you've built a fantastic foundation today. You can navigate, build, inspect, and safely destroy. But what happens when you need to search through thousands of files for one single line of text, and you need to do it in seconds? You know how to walk the path now, but next time, we're going to learn how to sprint. Keep exploring, stay safe in the shell, and we will see you in the next explainer.